Let's try going the other way around. So when you see a chemical name, you should also be able to write the chemical formula. So let me go over the rules first, and then I'll show you how to do it. So first, you write the chemical symbol of the first element, which is the metal, and then the second element, which is the non-metal. Just always write it in the order that you see. We write the charges of each of those ions. Remember, we wrote the charges in your periodic table yesterday. We're going to do something called a crisscross. And I'll show you what that is in a second. So crisscross the numbers, write them as subscripts, which means small numbers on the bottom. And reduce your subscripts if you can. Let's try some examples. Magnesium chloride. So again, if you got your periodic table, magnesium is Mg. Notice how I always write my first letter with capital, but my second letter is always in lowercase. It's like if you write your name, you always write your first letter with capital, but the other letters are lowercase. Chloride or chlorine, find it in the periodic table. Cl. Okay, now can you find the charges? If you look on top of magnesium's group 2, we wrote yesterday a 2 plus or a positive 2. So write that on top of, or like the right top corner of magnesium. Chlorine's charge, find it in your periodic table. It should be 1 negative or negative 1. Okay, we have our charges. We're going to crisscross. So crisscross my numbers. So the numbers on the top represent charges. What charge is magnesium? 2 plus. And what charge is chlorine? 1 minus. It represents each ion's or each atom's charge. The subscripts, the small number on the bottom, these actually represent how many atoms do you have. So this is the number of atoms. So I have 1 magnesium and I have 2 chlorine ions. When we write our final answer for the chemical formula, we don't include the charges. We only include the number of atoms. So it should look like this. MgCl2. Do you notice? I dropped this 1. When your number of atoms is 1, you can actually leave it out. Best practice is to leave it out. If you write a 1, that's okay, but we typically don't write 1. So it's just MgCl2, and there you go. There's your chemical formula. We'll try another one. Calcium oxide. So again, calcium in your periodic table, find it. Ca. Oxide is oxygen, so find oxygen. Chemical symbol is O. Find the charges. Calcium has a charge of 2 plus on your periodic table. Oxygen has a charge of 2 minus. Again, these all come from your periodic table. So look back to your periodic tables. Let's crisscross. So 2 and 2. Again, the top is a charge and the bottom is a number of atoms. And you might also notice when I write the numbers, I don't bring the plus and the negative with it. You don't have a -2 number of oxygen or calcium. That doesn't make sense. You're counting 1, 2, 3, 4, 5. So we leave the sign out for the number on the bottom. So if I clean up a little bit, calcium 2, oxygen 2, that's what we have so far. But remember the last step in the rules was reduce your subscripts if you can. So instead of a 2 and a 2, we're actually going to reduce it by dividing it. This is a math. So dividing it by the lowest common factor. Lowest common factor? Yeah. So we're dividing it by 2. So I'm going to reduce and reduce. If I divide 2 by 2, you have 1. If you divide 2 by 2, you have 1, right? So calcium, I have 1. Oxygen, I have 1. But do you need to write the ones? No, we just said you can leave out the ones. So let me get rid of them. So there is your final answer. When you can reduce your subscripts to lower numbers by dividing a common number out of it, you want to always reduce. Okay? So I had to reduce. If you think about the charges, maybe one last thing I'd like you to know. The net charge or the overall total charge of any chemical compound has to equal 0. You're putting together some positive metals and negative nonmetals together, and in the end, all your charges need to add up to 0. So let me show you one last way to check. Did I make my compound correctly? So net charge, I have 1 calcium, because it's a 1, right? 1 calcium, which has a charge of a positive 2. Remember that charge comes from just the periodic table. Maybe I'll erase this. Oops. And let's add the charge. There is 1 oxygen, which has a charge of -2. So if you think about the overall total net charge, +2 and -2, and they cancel out to 0. That's perfect. Our chemical compound has a net charge of 0. It's happy. Let me go back to our previous example and let's find the net charge here just to show you and confirm. I have 1 magnesium, right? Oops. I have 1, which has a charge of +2. I have 2 chlorines, which has a charge of -1. So if I add the charges together for all the numbers of atoms that I have +2 and again a -2, which gives you a 0. Okay, so the net charge is just to show you that my chemical compound is stable. It makes sense. It's just a way of checking for you. Alright, so if you're done this, I'd like you to flip the page and answer some of the questions on the back of the page. It should take you like 5 minutes. When you're done, you're going to go and ask for the naming package. It has a lot of questions. We're not doing all of them all at once. You're only going to do the first page, which is called Ionic Compounds, Naming Practice, I think. Numbers 1, A to J, and number 2, A to J. So basically the first page, left-hand side. I'm going to check all your answers, so it needs to be finished today. Okay? If you have any questions, feel free to message me.